Just imagine a drawing app which made even drawing something quite complicated like this fan so easy that you could do it in 5 seconds. The proof is in the eating, as they say. I'm copying the fan blade, the single fan blade that I've drawn. There it is. I'm going to ask to have 30 copies distributed around this circle. I think that was comfortably under 5 seconds. So, what are you looking at? You're looking at Draw Exact. It's our brand new drawing app we've launched. The emphasis is on putting you in charge of the geometry. So it's not so much about artistic drawings, more about geometrically accurate drawings. It's completely free. Our design priorities, when we made it, were to make it easy and simple to learn and to use, but not at the expense of power and capability. So we say quietly formidable to mean it's got some really quite sophisticated drawing techniques hidden away in that simplicity. We also wanted to make it really enjoyable to use, and for us that means mainly being very fast to use, but also reducing distractions so that when you're thinking about making your drawing, there's not too many things to distract you from just thinking about what you're trying to draw. There's no software to install. All you have to do is go to drawexact.click in your browser, which is exactly where I am making this video. It's as simple as that. So this is a quick introduction. I'm going to just use a few of the built-in examples to give you a very quick tour and a bit of an outline of how it works so that you can decide whether it might be something you're interested in. These are the example drawings you see when you go to Draw Exact, and I'm going to use these to give you your guided tour, and of course you'll be able to play with exactly the same drawings if you decide to come and have a look. So let's look at one which is based on an engineering drawing. Draw Exact is a general purpose drawing program. It's not just for engineering drawings, it's for all kinds of geometrically oriented drawings, but I'm just going to start with an engineering example just to give you a bit of a flavour of one of the types. And engineering drawings need these kind of line styles, but they also need to be able to you need to be able to put on dimensions quite easily, which I think we've succeeded with. Let's see what you think. I want a horizontal dimension from that point to that point, and I want the text there. It's as easy as that. So that's engineering drawings. Let's move on to another type of drawing. Now let's look at a drawing which is for a graphics design. You'll see that this drawing is mainly based about circles, which have been, I like to think of them as rolled together so that they touch tangentially like this, or like that. And what I'm going to do is just start off with how you draw a line, how you draw an arc, and just very quickly work up to how you might set about making this type of drawing. So, good place to start, draw a line. I'd like it to start there and go to there, and then to say draw a line. And that was drawing a line from one point to another, but what if I wanted to make a copy of that line that was parallel to it and went through there, through that point? Well, that's the same command, but it'll know that I want to make a parallel copy because I've selected a line and a point rather than 2 points. And I could keep this. There's actually 4 ways you can draw a line. Here's one more. If I select a point and an arc, it knows I want tangents, like that. I'm going to draw a line again, like the first one, point, point. And I could go over here and press line again, but there wouldn't be much point in doing that because you've already seen that. But what I want you to see is these little letters that are written next to the commands, and just browse the commands. Line, arc, text, rectangle, ellipse, fillet, dimension, delete, grow, move, undo, zoom to fit, save, etc. And they've all got their first letter. You can press the key instead of coming all the way over here. And when you're learning, you use this menu, obviously, but you very soon get used to this little language of these words. They're very simple English words. And as soon as you think line, you know you can press L instead of coming over here. And that speeds things up enormously, but it also means you can stay really focused on your drawing area. So I might be focusing on this drawing area and saying, well, I want to draw a line from there to there, and then just press L for line. And in the rest of this video, I'll be saying, when I want to indicate that I've done a command, I'll be saying L for line, U for undo, D for delete, A for arc, etc. Speaking of which, U for undo. So let's talk about arcs. It's actually quite analogous, really. I can select 2 points and say A for arc to get a circle. I can make a parallel copy through a point by doing A for arc like that. Something else I can do, which is a bit different, is one of the things that's most difficult to do if you're drawing manually is to do this. I want an arc that starts there and goes through there and ends up back at the bottom of this circle. That would be quite a tricky thing to construct manually, but you just go away for arc and it does it. You can grow lines and arcs as well, which means to either make them longer or shorter. So if I wanted to make this longer, I click the line and say grow it to there, G for grow. I can make it shorter too, like that, G for grow. Sometimes you want to go to an exact point like that, G for grow. And you can do the same with arcs, G for grow. So the combination of drawing lines, drawing arcs and growing them is probably the thing you'd spend most of your time in Draw Exact doing. So now let's look into some of the specifics for this drawing. How do you create these tangential relationships like that circle tucked in there? Let me show you. There's a thing called a fillet command. So I'm going to emulate that by putting a circle in here. And to get an idea of a suitable radius, I'm going to move over to there and look at this coordinate readout. It's telling me the x, y and r, the direct distance from this point. And the angle, by the way. So in this case, the radius, or the r, is 1.026. So say I wanted to be a bit more exact and make it in exactly 1 unit circle. I can, for fillet, I put the radius in there. And then I can say I want a fillet between that arc and that arc, roughly passing through there, F for fillet. And I can grow it. And I can grow it all the way back to make a circle to get back to something akin to this. And now let's look at how you might trace out an outline in a different colour like this. I'm going to select that because it's got the line style properties that I like, and I'm going to go K for keep. And now if I were to, next thing I draw, it will adopt those line styles, undo. So now I can use that arc through 3 points command to just trace out parts of something I want. So for example, I might say I want an arc which goes from there to there to there, A for arc. So you can see now the sort of building blocks of how I produced a graphics design like that. We'll leave that one there and I'll show you another example. When people ask me why Draw Exact, there's lots of drawing apps. I often say, well, there's 2 superpowers in particular, sometimes 3. And I think the next thing I ought to do is show you those 2 superpowers. Let's start with the first one. Imagine I was trying to draw these set of bicycles spaced along this angled line. Now, as it happens, I've already got a bicycle, but it's much too big for what I want it for, and it's horizontal, whereas I need them angled. Now, this is going to let me show you the copy and paste superpower. And it's a superpower because it's not really like copy and paste that you're used to. It's copy and paste taken to another level. I think actions speak louder than words here. I can copy something I've already drawn like that. And the first thing you're going to notice is that unlike copy and paste and everything else, you can see what you've copied. And we're in a sort of preview situation now. I can say, where do I want to put this down? And you can kind of experiment. Sometimes you do position something just freehand. Imagine I was just jokingly trying to get that to sit on his head like that. But that's not what we're going to do here. We want to get it accurately aligned down here. And of course they have to be smaller and angled before I can do that. And that's the next part of the copy and paste superpower, because I've got these controls over here to actually change what I've copied before I paste it down, and I can experiment and riff on the ideas. So one of the things you can do is scale, rotate and mirror. And by default it does a scale of 1, which of course does nothing. If I change the scale to 0.3, I've now got little ones. And as this prompt down here suggests, I can add a rotation. -30. So I've now got them both smaller and angled exactly the way I want down here. And I now might want to experiment about spreading them along this line. So I can say, well, let's try 12 copies and see what happens as I go near the line, get a preview like that. And I can say, well, that's nice, but now I've looked at it, I want them to be smaller and get more on. So how about I change the scale to that? This is what I meant by experiment. And maybe if I think 12 is now a bit sparse, so how about if I change that to 18? Oh yes, I like the look of that. So I'm showing you that partly to show that copy and paste is taken copy and paste to new levels with the scale and rotate. There's also mirror, which is very useful. If I copy that again like this, that cyclist at the moment is cycling across the page from left to right. But if I go scale 1 and then mirror about a line that's at 90 degrees, he's turned around and is coming back the other way. Which is a bit of a laugh, but it's actually very useful because often things have got a left hand and a right hand. And often when you draw something, it's got a lot of lots of things you draw have got symmetry, and it means you only have to draw half of it, because then you can just copy and paste what you have drawn, mirror it, and pop it down, and you've got the other half. And the other thing is, if you think about it, now that when you copy and paste something, you could scale it, mirror it, and rotate it, what it means is you can build up a library drawing of things that you draw often, like a door handle. You can draw your favourite drawer handles and stash them away in a library drawing. And you can copy and paste between drawings, and depending on the scale and the type of door you were putting the door handle on in the other drawing, you could just scale it, rotate it, mirror it to suit. So that's the first superpower. I suppose I'm kind of obliged now to go on to the second superpower, so that's what I'll do. We call the second superpower the infinite canvas. This boat is 5,000 something units long. I said units rather than millimetres or inches or anything else, because I was thinking in millimetres when I drew it, so I know it's millimetres, but DrawExact doesn't know about units, it just knows about the numbers you type in, so you're completely at liberty to use whatever units you want, and people will clearly want to use different ones. I'm sure there'll be somebody one day that draws something in fathoms just for a laugh. So, let's talk about zooming in first of all. The canvas is infinite in the sense you can zoom and zoom and zoom and zoom, and you don't lose any accuracy. Let me show you. I'm going to zoom in the front half of the boat just by dragging a window. I'm now going to focus just on the name part, and you can hopefully see in the video now that there's something happening inside the letter D, so let's go and take an interest in that. Aha! There's some details inside that eye. What on earth is going on in there? Ah, it seems to be a reflection of my face looking back at me. The reason I'm doing this is if I just remind you that we started out at a drawing in which the boat was 5,000 and something millimetres long. We're now looking at some details which are, if you look at the R in the coordinate readout, 0.027 millimetres. So you can work on details that are this tiny in the same context, in the same drawing, as working on stuff that's 5,000 millimetres. And that's really useful because it means that you can put all the details at various levels of hierarchy inside all in the one drawing. And it still works very, very fast, and it's much easier to manage drawings if all the information is in one place inside one drawing, particularly if you want to make changes, rather than have a separate set of drawings for the details where you've got to then coordinate changes across the drawings. I better show you zoom out. So I could just zoom out one step at a time with the zoom out. So I emphasize out, zoom out. So it's O for out, 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 out. But in a situation like this, you probably want to just do a one-step zoom to fit. All these zoom commands are down here. Zoom to fit is just Z, zoom to fit. So I'm back at the whole thing. So you might think I've finished talking about infinite canvas, but I'm afraid not, because it's infinite the other way as well. If I keep zooming out, I can do this, which, zoom to fit, there is a point for. Consider this, if I make a complete copy of the whole drawing, zoom out and think, well, I'm going to consider making some changes, but I don't want to commit myself yet, so I'm going to pop down a copy. And I've decided I want to go sailing when there's less wind, so I need a bigger sail. You get the idea. I'm just using this as a bit of a jokey example of how you might make a modification and experiment with it without losing the old one to start with, and you can copy and paste bits back and forth. Sometimes you might copy out some details, work on them over here, and then bring them back in. So that's sort of infinite canvas the other way. But while I'm here, there's something else I want to show you. The last thing I copied was the whole boat. Now I don't actually have, if I want to use it again, I don't have to copy it again. I can use the bring back command, bring back. And so there it is. Now I'm going to zoom out so I've got loads of space, and I'm going to go completely bonkers and put in loads and loads of copies. And the reason I'm doing this is to make the drawing very, very complicated in terms of the number of lines and arcs. Just to remind you about, we've got all those lines and arcs inside the swallow in there. There's really some quite subtle curves and things in there. Even remembering the pupils, there's all those little curves. There's also details on the rudder, like that aren't obvious at first sight, like these fillet radii. So there's probably several tens of thousands of lines and arcs and bits of text in this drawing now. But I want you to notice how quick it still is. If I now press Z for zoom to fit, boom, it's instant. And drawing is instant too. So that's actually very, very unusual. It's probably a first in drawing apps that work inside the browser. Normally apps that work in a browser have very strong limits as to how far they can go with the sort of computation involved. So that's important, because it means that when you're drawing, even on quite a complicated drawing, it never slows down. It just stays as sharp as a button, which helps you concentrate and doesn't distract you by having to sort of wait or find the behaviour sluggish. Let's go back down to look at some of the construction techniques. We're going back to basics again. You've seen fillet radius production, you've seen tangents being produced. But look here, we've got normals, you've seen some parallels, I'll do a few more. Normals, radials, ellipses, coordinates. I want to show you how just the day-to-day drawing is made very quick and very accurate and very intuitive. A normal is a line at right angles to another one. And say, for example, I wanted to draw a line that started here and went up here at right angles to this one. And I don't want to have to bother to find out what angle this line is at the moment. I can say, well, I'd like the normals ray patterns, so I've now got a helper for an automatic right angle, and I can draw up there. I do the same thing on an arc, in which case the normal pattern is taken to mean radial. So that line is now on track to go through the centre of these arcs. So that's normals and radials, very useful. You've seen parallels, I think, just to remind you. Parallel arc through that point, A for arc. Parallel line through that point, L for line. Tangents, you've seen most of them, I think, but let me just temporarily draw a couple of circles to illustrate tangent, the one type of tangents you haven't seen. You've seen point to arc tangent. What you haven't seen is the tangents between two arcs, L for line. It gives you all the tangents that are available, and you just delete the ones you don't want, like that. Undo, 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 undo. Ellipses. This is an ellipse, and to make them, you either first of all draw a rhombus, like this one, or you draw a rectangle. I'm going to illustrate it with this one. I want an ellipse, please, between those two corners, the sharp corners of that rhombus, E for ellipse. That's particularly useful for isometric drawings. This type is more useful for putting labels inside, for annotation on diagrams where you want lots of labels and things. Now, coordinates. Coordinates are very traditional in drawing apps, but we've made coordinates simpler because you only really have to think about one of them at a time. And if I just delete this one, and the same story, I want to line at right angles, automatically at right angles to this one up here, but I want it to be, at the moment the rays are 20 long, I want those rays to be, let's say, 8 long. And I want to go to those normals rate modes. And now I've got essentially a polar coordinate. Right, and that is exactly 8 long. So polar coordinates are kind of just there, but if you think about it, so are Cartesian, because the default ray mode is this, and that's an x Cartesian coordinate, and that's a y Cartesian coordinate. So you can get things in exactly the place you want. I haven't shown how you get text exactly accurate, but with text as an anchor point, so if I make that my point and say I want text, well, T for text, it always says text 1, because what you then do is you select it and you go properties, and you can change it to right justified, for example. You can make it a bit bigger, You could say, well, let's angle it up at 5 degrees. You can change the colour, and of course you can edit the text, and you see it being edited in situ. Hello. I think I'm going to make it a bit smaller. 3. And you can put in line breaks like this. Goodbye. And I don't know whether you noticed, but it was appearing in the drawing as I was doing it. So if you see the if is appearing, if I start something, and this helps you compose how you're going to put the line breaks and indentation in your text as you're typing it, because you see it in context in the drawing at the same time. So that tried to get across how just the day-to-day construction of lines and arcs and text, most of the things you typically want to do are just there, instantly accessible. Let's go on to another example. A lot of people use DrawExact to explore the geometric relationships between things. This is a great example, the picture of a runner. You'll notice that that part of the runner's leg is just off vertical, and it's his heel that's touching the ground. Whereas in this one, a bit later on in the stride, the knee is more flexed and it's moved now so that its toe touching the ground. And that's what I mean by exploring relationships. And what I'm going to demonstrate is how, if all I had was this drawing, how I can very quickly generate that one and similar ones, like this. So we'll start off by making a copy of number 1. Zoom out so I can pop it down here, and we'll just work with this one. First of all, we'll chop off his leg. I feel like a surgeon in an operating theatre who's got virtual reality, but it's gone native and it's not working. I'm going to cut off his leg. Copy. Oh, the pain. Put it down there. And the reason for that is I can now delete it from the first place, like that. I can pick up this one and say, well, what I really want is that it got on legless. I want to rotate it -30, and then I can pop it back on there. And there's a bit of tidying up to do, which is exactly what the grow command is good for. So you see how quickly, just delete that, see how quickly you can generate these diagrams to explore, I think the proper word is kinematics, but geometric relationships between shapes. That might be where you want your fridge in your kitchen, or what's going to happen when you open the door, or something a bit more elaborate like this.